Well, how can we tell if a chemical reaction has occurred or not? It can be a little tricky sometimes. If we could zoom in and look at the atoms and molecules and see what they're doing, it would be really obvious what was happening, but we can't. On that molecular or atomic level, we see that atoms are combining with other atoms to form compounds. If we start with molecules, we start with compounds, they're coming apart, and we're forming new molecules. Or we see that atoms in one molecule are changing places with atoms in another molecule. Unfortunately, we can't see that, so we need other clues as to whether a reaction is occurring. So there are 4 different forms of evidence. A color change. If you see a permanent color change, that's a good suggestion that you have a chemical reaction occurring. You can buy these really cool spoons for feeding your baby. When you put it in water that's too hot, or in food that's too hot for your baby's mouth, it will change color, and that is saying, hey, stupid, your food's too hot, you're going to hurt your baby, don't put that in their mouth. That's what the color change is telling you. Why does it do that? How does it do that? It's a chemical reaction. The heat causes a chemical reaction, and the color on the spoon changes. If you stick it in the food and it doesn't change color, you're fine. Go ahead and feed the baby. Another form of evidence is when you see a solid form. You take 2 solutions. So here we have this clear liquid solution, and we have this one that looks like water. We pour them together, and it almost seems like magic, and we get this rusty colored cloud forming. We know this is a solid because we can't see through it. This also has things dissolved in it, but they're individual ions, and so it's still a clear solution even though it has a color to it. But when we get this cloudiness forming, that's a solid. If we wait, that solid will settle down and we'll see a layer of it on the bottom. It's a bit like taking some water from the river and stirring it up, and all the silt from the bottom of the river comes up and floats in the water, and it looks all murky and disgusting, right? If you wait, all the silt, the solid particles will settle to the bottom, and the water's clear above it again. So formation of a solid. Formation of a gas. So you drop an Alka-Seltzer tablet into water, and this results in a gas evolution reaction. There's a reaction, a chemical reaction occurring that's forming these gas bubbles. We see this fizzing, and the bubbles rise to the surface. When you see fizzing like that, or bubbles forming, that's indication of a chemical reaction. Another one is energy changes. The energy could be in the form of heat, or it could be in the form of light. If we see heat being absorbed or emitted, if the solution gets warm or gets cold, probably a chemical reaction occurring. If we see light being given off. So here we have a natural gas burner. We're seeing both forms of energy. We're seeing some light being given off, and we're seeing energy in the form of heat. It's going to get hot. Here, a chemical cold pack. You break the little seal inside, and you mash it around, and it gets cold all by itself. That's neat, huh? I would say it's cool, but that's, it's kind of a bad pun. It's a chemical reaction. A light stick. My kids love these things, glow sticks. You buy them and you break the little glass tube inside and you mix it around and they just start glowing. That's a chemical reaction that's occurring. We can see that it's a chemical reaction because there's light being given off. That's evidence that new substances are being formed and old substances are being destroyed. We have to be careful with these things, though, because we can be fooled. So you put water onto a burner and you heat it up, and bubbles form. Is it a chemical reaction? No, it isn't. Any question?
Is that because it's not changing its form?
Right, it's not changing from water into something else. It's just changing from a liquid into a gas. So this is a state change, and we learned before that state changes are always physical changes. If we could look at the particles, We've got our little Mickey Mouse head water molecules, and when they boil and go into the gas state, the particles are the same. If you collect that steam and cool it down, you still have water. So we have to be a little bit careful when we look at the evidence of chemical reaction. So you can sometimes see one of the evidences and it's not a chemical reaction. You can also have a chemical reaction occurring and there's nothing that you can detect with your senses to indicate that it's a chemical reaction. So those are just guidelines. Okay. Which changes involve a chemical reaction? And then the hard part. Explain your answers. So he says C. Is C a chemical change? A chemical reaction? Yes, it is. What happens when we burn wood? It turns to ash. So its color has changed. Is there heat or light given off? Yeah. So we've got multiple forms of evidence, right? So this is definitely a chemical change. Are any of the others chemical changes, chemical reactions?
No.
Actually, some of them are. So A is. So for A, we have butane burning in a butane lighter, and then this one is similar, butane evaporating out of a butane lighter. So burning is telling you this is a combustion reaction. The butane's reacting with air. You've lighted the lighter. You flicked your bic, right? So you've got a flame, you've got heat and light being given off. This is a chemical reaction. If you flick the lighter, but you don't get a spark and get a flame, and you're just holding it open, what happens is the butane in there is just going to evaporate. Evaporation is a term describing the change between a liquid and a gas. That's a state change. It's not a chemical reaction. How about dry ice subliming? Also a state change. In a state change, there's no chemical reaction. Any questions? There will be a question, something like this on an exam. I won't try to trick you. You could still feel tricked, but I'm not going to try to trick you, okay?